Thanks, Sandeep, for that introduction. I'm going to today talk about Declarative. It's a way to create backends in minutes and still keep the application flexible, performant, and production ready. So this talk has essentially three sections: the why, what, and how. So in why we'll talk about the need, in exactly what we offer, and how is we're going to talk about how do we build it, how did we build it. So this is a project that will be open source at some point. So we'll talk about why part. So why do we need a backend that can be created in minutes? So if you look at current state of the world, we have clients such as services, tools, but also mobile application, desktop applications, and so on. But we have the information in some backend, some databases such as Postgres, as well as maybe REST API available or GraphQL API available to you. And a myriads of cloud services, search engines, Mailgun, things like that. So what we do is we create something called backend, and the backend offers some API, maybe GraphQL API or REST API. And the clients talk to through this API to the backend, and backend in turn talks to the data sources. The way currently, however, when implement the backend is we typically write some sort of data access layer, which knows how to talk to the REST services or Postgres and other S3 and so on. Then we introduce something called service layer, and service layer usually would take care of things like security, taking the data, manipulating it, probably talking to multiple services and bringing that data together and so on. And finally, we have API layer, and API layer's job is to expose that data through appropriate APIs. So for GraphQL, we'll write resolvers. For REST API, we will write controllers here. Now the details may vary, but essentially you have to take care of all these things: accessing data, combining them together, applying security, and exposing it. The way we right now do is we end up writing lots and lots of code for doing the same thing. And even if you look at from one backend to other backend, there's a whole lot of commonality between them. So what we are proposing instead is to have a declarative backend, Declarative, and I will talk about what exactly it is in a minute. And that way we don't have to write all that much code. So what is Declarative? Well, Declarative is a declarative language. So it allows you to express domain model, access control services, business logic, and system-wide concerns in a special language that makes it very easy for anybody with some programming background to be able to do that. It's an interpreter and compiler. So that language, during development mode, you can interpret it and then you can get your backend. But when you are finally ready to ship it, you will compile it and you will get an optimized binary that you can deploy to any environment. And there's also a suite of production tools which allows you to for example, deal with database schema migration, and so on. So next 5 slides, I'm going to swap between showing a slide and giving a demo. So first thing we need to, when we want to create a backend, is to deal with domain model. So in case this domain model, we're going to come with a very simple domain model. So we want to do concept management. So concepts are held at a venue, and venue can host multiple concepts. So let's start a demo. So what I'm going to do is I have essentially a blank slate. This auth code that I will use it later to save time. But right now we are going to create a file called index.clay. And now I can write my model. So I need to express my domain entities. So concept is the one. Int, and it's a primary key. And I want it to auto increment. Then I want it to have title, and then I will say, is it a published concept or not? So that allows me to work on the concept details and not have to publish it. That's it. So I wrote 5 lines of code, and let's see what can I do with this declarative backend. So I just start the server called Clay and say serve. So basically serve the backend. And it started the backend in about a millisecond. And then if I go to this thing, I get GraphQL API. So let's observe what is it. So you have query, probably one font. So we get to basically get a concert given an ID or a bunch of concerts given a filter and ordering and so on. We also get a bunch of mutations, creating, deleting, updating concept. But what we are interested in further connection between the concept and venue. So let's continue with the domain model. And we're going to say model, venue, ID, same thing, int, it's a primary key, auto increment. And we're going to have name of the venue and also have published here. So we have now model, and if I were to go to GraphQL now, let me actually start in watch mode. So it will pick up the changes as we do. And if I go here, I will get here queries for venues and similarly mutations for concept and mutations. All right, so what I'm going to do now is I want to create a database based on these parameters. So what I'm doing now, create. So it basically gives me, oh, sorry, actually I need to do one more thing. I need to create here a connection between the two. Let's say venue, column, ID. And basically concept has a venue, and venue can be hosting multiple concepts. Have a set of concepts. Almost right. All right, so let's do this again. So it now gives me tables to create and constraints to follow. So let me just copy this. And go to another terminal and create a database. And paste it. All right, so let's go back and start our classer. So let's reload this, nothing should change. But now what we're going to do is we're going to start using those queries. So first thing, let's try to get what are the venues in the system. ID, name, published. And we execute it and we get back nothing, because obviously we just created a database and we didn't really add any venues. So there are no venues in the system. So what I'm going to do is I'm going to start invoking some mutations. So let's create first venue. Venue, we can give data. So this is just a graph, automatically created GraphQL API. So let's call it v1, venue1, publish. Let's make it publish true and get back its ID. So I created a venue. Let's create a couple more venues. So v2 and v3, but v3 we are going to make it published false. So similarly, let's create a few concepts and connect them to database, connect them to a venue. So I am going to create here concept. Concept needs title. Let's call it C1, published, sure, and which venue we want to host at, the ID 1. So we're going to create some symmetric data. So venue concept 1 is hosted in, so we can do it in one shot. Let's do that way to save time. So I'm going to create concept 1, concept 2, and concept 3. Let's say this is C2, C3, make it venue 2, venue 3. And make it false. And we have to give different names to each of these. So 2 and then 3. It's just the GraphQL allows you to run multiple mutations in one shot. So we are going to just use that. And so we created 3 concepts. So now if I go back to my query, so in fact, let's just try. So I want to know all the concepts in the system. I want to know their IDs. I want to know their title. I want to know if they are published. I want to know what venues they're hosted at, ID and name, and are they published. And if I want, I can further ask answer. There's no problem. You can ask deeply nest as much as you want. So if I execute it now, I get back all the data. So I get C1 being hosted at V1, C2 being hosted at V2, and C3, which is not a published concept, it is also is hosted at V3. So what we have so far is, let's see how many lines of code we wrote. We wrote like 13 lines of code, and we have full-fledged GraphQL API available that allows you to do all the creation, deletion, update, etc., and still deal with the relation between objects and so on. But as you can see, this is not the API you will directly offer because you don't have any access control. Anyone can add venue, anyone can delete venue, etc. So what we want is, we want some way to secure your model. So securing this model, what we need is, we need to first describe what does it mean that somebody is accessing the system. So that concept is a context. So basically, context is anything that you can create it from request. So this is part of the flexibility. So you can create it from header, request, anything. So we are going to create it from JWT token. So I want here ID, which is an int, and I want to say it comes from a JWT subject field. Similarly, I want to say it has a role, and it comes from JWT role. The last thing I want to do is, I want to say who can access these objects. So if you want to do query, you can access it as long as if the concept is published, or you are in admin role, or sorry, if you want, who can mutate it. It's almost got right. Okay. So you have this access control that says anyone can query it if the object is published or the role is admin. Mutation, however, requires that you must be in admin role. So I'm going to apply the same rule to venue. And now let's go back to our GraphQL and let's run the same query. Now, instead of getting 3 concepts back, you got only 2 concepts back. That's because our rule is that if I'm an anonymous user or a non-admin user, I should not get back published concepts. So this portion. So what I'm going to do is, I am going to add an authorization, and I already have created a JWT token prior to save time. And this token basically is has an admin role. Now, if I execute the same command, I get back everything. Similarly, if I go back to my history and say, okay, I created venue here. So if I did not specify this, it would say you are not authorized to create it. But if I specify this token, which is admin privilege, I can go ahead and create the venue. So now we have secured our model, and we can specify complex rule if you want. The next thing is data model will get you quite far. That's really the major part of your domain modeling, is like data and its relationship between the objects. But what if you want to go, and you will have to go to, for example, Stripe to buy a concert or send an email, or even to authenticate with Google, you have to go back and verify the token. All these things require that you access external services. So we're going to start writing that external service. So I'm going to create a simple example, not quite Stripe, but almost giving the same flavor. I'm going to create a service, and let's call it, actually what I'm going to do is, so there is this service called JSON placeholder. So it's basically, you can go to URL and it will give you a to-do item. So we want to basically make access to such service possible from within Declarative. So I am going to say here a to-do service, and I'm going to have a query, and that query will be to-do gets an ID, given an ID, it's going to return 2. But if I save this, so it says like, by the way, this is the whole language in Declarative is all type safe. So you cannot make mistake and it will not catch you. So for example, if you were to say here published X, it will say, oh, I don't know this field. Or if you said here title, for example, or name. So it will tell you that this should have been a Boolean, but you gave me a string. Anyway, going back to our thing, published. So to-do is not a known to the system. So we're going to let it know that to-do is, and what we want is basically this payload representing this payload. So this almost looks fine to me, except I think this should be title. There's a user ID, but we don't have to get every data. No, that's not. This code completion is by Copilot, GitHub Copilot. It gets almost right, but not always. So now it's saying next is, all right, this query, but what does this even mean to execute this query? So we have to supply here an external annotation to say, okay, the to-do.TypeScript. Right now we are supporting TypeScript, but and JavaScript, but we will support WebAssembly and other languages so that you can write your services in. All right, so let's create this to-do.ts. What I need to do is I need to write a function to do exactly what the query might specify. So it takes a parameter number. Okay, this should be an async function. But I am going to do a fetch promise. I'm not going to as nice, but so what I'm going to do, however, is I'm going to say let r equal to fetch, and I'm going to copy this URL, this portion of URL. And I'm going to await on this, and then return, yeah, r.json. All right, and let's start the service. So now, if I go back to my service and reload it and see what are the queries available, I get an extra query called to-do. Let's invoke this query. To-do ID, let's give 4. And what can I get from it? I can get all the things I described that to-do may have. Title completed. And I got back data. So similarly, you can extend it to any other service. You can fetch it from Stripe. You can post it to any other service, get blob from S3 or whatever else you want to support. So the next thing we want to talk about is, okay, so external services are actually, let me show you one external and additional external service. And that's that using auth. So I'm, just to save time, I'm going to actually just copy paste an existing set of code. And it should be no surprise to you, except for one small thing, which I will explain. So I want to add authentication to my system, and simple authentication, email, username, password, that sort of thing. So what I have is I introduce a model called user, which has, as you expect, a pretty standard stuff. In a realistic model, you will have verified, is it locked out account, and so on, but roughly it matches what you would typically do. And the query and sign up look very much like the query here, except one is query, other is mutation. But there is also this new thing called inject. So sometimes services need to access back the data itself. For example, in case of auth, if you want to do a sign up, you want to go and execute query to add this user to the database. Or if you want to do login, then you want to get the password and then do a comparison of the password and then return a JWT token. So all these things need accessing data, and that's available through this creative object. So if you look at the API, the injected parameter will not be seen in the API. So login, you will see email password, but not creative, because creative is supplied by the system. You also have, so you have business logic where you want to say, rather than invoking directly login, sign up, get me to do, you may also have situations where when certain things happen in your system, you want to take some additional action. So for example, when a receipt is created as a result of Stripe checkout, you want to invoke MailChimp to send an email saying you have bought ticket for concert and see you there, stuff like that. A different flavor of this is you want to apply similar logic to a part of your application code. For example, you may want to say, okay, this Stripe checkout, receipt, and sending email is a critical part of your system. This is where money is made. So you might want to say, let me audit that system. So let me apply some logic when you invoke a Stripe call or send an email or receipt is created. Let me put that information into some auditable format. Or you may want to say that I want to check observability of this system. So if exception happening too often, or if time is much longer for each query, then I want some observability so that I can get alerting and things like that. Or I might want to apply rate limiting to the whole system so that if I get the website get abused, then I can pause those users and not serve them for a while. So we are going to create this observability concern through a concept of interceptor. So interceptors look very much like a service. In fact, they start as a service. So let's say timing service. And so we are going to, instead of writing a query or mutation, we are going to say, I want to write an interceptor. And then you can say, interceptor gets access to these special variables called operation. And the operation basically contains information about the name of the operation that has happened and so on. So if I save it now, it says, okay, I need to have an external annotation. Call it. And this time, just to show a different thing, I'm going to do a JavaScript. And it says you are missing before, after, around annotation for interceptor time. Because interceptor, you have to decide when do you want to apply. Do you want to do it before operation or after the operation has completed? Or in our case, we want to do it around it so that we can get time before, time after, and report that time. So let's do that. Around, I'm going to go around any query in the system. And let's create now a new file called time.js. Export. And that's not what I want. I want to say const start equal to performance. Now operation I want to invoke after that. So I can, the way to do it is proceed. And say const result. And then I want to get, and that's correct. That is also correct, almost. Name is a function, and then return result. All right, so let me start this server and let's do query. So we are going to go and say, get me all the concepts. And it says, okay, concerts invocation took 49 milliseconds. If I invoke again, it will be much smaller because first time the query Postgres will optimize it, and next time onwards, I will get much faster result. So by just adding like 7-8 line of code in TypeScript, JavaScript, and a few more line of code in Clay, you got performance consideration also. So the rest of the presentation is I'm going to talk about how. We got about 5 minutes. So I think I'll be okay. So how does this whole thing happens, right? So we start with the model that you supplied. So model is supplied has a bunch of clay files, and those clay files, we pass it through a compiler. And when I was doing clay serve, I actually was passing through an interpreter, but they do the same thing. It first parses it, then type checks it. That's why you saw, like when I said self.title or, it said, okay, that's not type checking because it needs to be Boolean. And then it builds a model. Model basically has all the types, all the queries, mutations, interceptor information, everything is now figured out. And then finally you have execution, where you have query mutation plan, like when the query comes, what should be, when a GraphQL query comes, what should be SQL query? What should be access control rules applied based on the roles and user accessing it? Any external services or interceptor that needs to be invoked. And then this thing just runs. So there's no code generation, as I mentioned. And now you have access to GraphQL API and soon to the REST API. All of this thing is written in Rust. So as a result, we get pretty good performance. So if you look at, for example, let's look at, am I running it? Yeah, so Clay. See, it's taking 9.3 MB of memory. So this is all this thing, GraphQL API and everything available in just like about 10 MB of RAM. So this really shines, Rust shines in these things. Low resources, extremely fast startup time. So right now, if I were to do, I'll show the startup time point a bit later. And it's safe because in Rust, you cannot have memory, dangling memory or crashes that are unexplainable. So we are using Rust in its, I'm very happy with it. So when it comes to deployment, you can deploy to your local machine as I have been doing, or you can put it in a Docker and deploy to any of the cloud services, or you can do optimized, serverless optimized build. And let me show you that part. So if I do here clay serve, so it took about 76 milliseconds to start. And most of the time I was actually spent in is bundling these files. But if you are doing serverless, you do not want to spend, you want as little as possible. So how do you do that? So we have this compiler, clay build. It basically creates this clay pot file, and now you can just run it as a clay server. And now it started in 0.77 milliseconds. Sometimes for the first time, it takes a while, but 0.77, so if less than a millisecond, our server started. And this is really important for serverless, because serverless, the time to respond to user is the time to process, but also time to start your server. So now we have reduced it to below a millisecond. And then you deploy to any of the functions. So for tooling, I already showed you GraphQL tooling, but we also offer a bunch of other commands. So the clay, I showed you the build to build the optimized binary. And also showed you schema create to take your model and create a database schema. But there is a reverse possibility. You can take existing schema and create a starter model and migrate database as your clay model evolves. A little bit more about clay build. You can actually lock it down to say, okay, I want to only not support introspection. I don't, basically you reduce all the things that you do not want in a final production build, and it will create an extremely optimized binary. And that's clay tip, right on time. If you have any questions, I will be out there in a special chat.